This assignment is the culmination of all of the division we have done up to this point. You know how to do everything. We're just going to bring it all together. I'm going to work number 36. X to the third minus 2x squared plus 4x minus 8. Before we do any dividing, how many roots does this polynomial have? 3, because it's an x to the third. What are the possible roots? Plus or minus 1, plus or minus 2, 4, and 8. Do I need to create any fractions? No, because the the leading coefficient is 1. All right? What about Descartes' rule of signs? There's a sign change, and there's a sign change. Oh, there's one in the middle. Sorry, I missed one. So positive could be 3. And then do I need to check negatives? No, because 3 is all of them. So there are no negatives. And you can see that. Maybe I'll do it just to show you. When you check for negatives, what do you change? Odd exponents. So this one's going to change to a negative. That one stays. This one changes, and that one stays. We have no negative sign changes, which means there are no negative roots. And then complex would be, in this case, 0. Are there any other combinations? 1, 0, 2. You can always substitute 2 positives for 2 complex, or 2 negatives for 2 complex. 1, 0, 2. Does that help me in my guess? I don't want to guess any negatives. How do you tell if 1 works? Add all the coefficients. 1 minus 2 plus 4 minus 8. Does that equal 0? Nope, so 1 didn't work. So it's either 2, 4, or 8. Okay? Or something that's irrational. But if it's a rational root, it has to be 2, 4, or 8. What should we try? 2? I put 2 in the corner. Am I missing any terms? Nope. 1, negative 2, 4, and negative 8. Drop the first term. 2 times 1 is 2. 0. That would be, 0, sorry. 4 and 8. Okay, so I now know one of my roots is 2. One of my factors is x minus 2. What equation, well, hold on, before I go there, what are the other possible roots? No, so looking at this list, 8 no longer applies. How come? Well, 4 goes into 4, so it's a possible. Once you simplify your equation and you get a new constant, that new constant creates a new list of possible rational roots. 8 is now gone. When I line up all of my factors, all of the constants need to multiply to be 8, and I've already found a 2. So the others could be 2 and 2, or 4 and 1, or something irrational or imaginary. What's that? 1 didn't work. So it's, oh, well, so we know it's not 4 because 1 didn't work. It could be irrational or imaginary. Yeah, we know what it is. If I write the polynomial x squared plus 4, does that factor into i's? So the factors would be x plus 2i and x minus 2i, and my roots are plus or minus 2i. And just to show you, is negative 2 times 2i times negative 2i equal to negative 8? Yep, you end up with you end up with positive 8i squared, but I squared is negative 1. Okay. All right, let's do We'll do number 56. Read off those coefficients for me. 4x to the 4 minus 44x cubed plus 145x squared minus 114x plus 20. All right. Now, this is a huge list of numbers, which is why we need all of the pieces at the same time so that we don't spend forever working on this problem. The factors of 26 are 1, 2, 13, and 26. Am I done? Nope, because the leading coefficient has 1, 2, and 4. So I've already got everything divided by 1. Now I need to divide by 2, but I don't need to divide everything by 2. Just the ones that don't simplify, just the odd numbers. So plus or minus 1/2 and plus or minus 13 halves. The other two simplify, and I don't even need to check to see if they simplify into something I already had. It's a guarantee. If it does simplify, we already have it or we will have it in the end. Okay? And then I need to divide by 4, and I just need to divide the 1 and the 13. So plus or minus 1/4 and plus or minus 13/4. Those are the possible rational roots. Now I need to do Descartes' rule of signs. Positive, negative, complex, and I check for regular sign changes. 1, 2, 3, 4. So they're either all positive or 2, 0, 2, or 0, 0, 4. So we know not to guess any negative numbers. Yes. We'll get to that later, but yeah. So looking at this, is 1 going to work? 4, try it in your calculator. 4 minus 44 plus 145 minus 114 plus 26. It's going to be pretty close. Somebody typing it in. So 1 doesn't work. I'm going to take 1 out of the mix. Okay. Should we guess a fraction? I wouldn't. What I like to do is keep the fractions until the end, because once you have a quadratic, then you can factor. Now, it might turn out that all 4 of them are fractions. We're not sure yet. Hopefully that's not the case. Actually, I know it's not the case, but you don't know that yet. Let's try to, well, the reason I know that all 4 of them can't be factors is there's no way to split that up, split 4 into 4 into 4 fractions. Does that make sense? The most we could have is 2 fractions, a 2 and a 2. Yeah. But if we have 1/2 and 1/2, that's where the 4 comes from. We can't have 1/2, 1/2, and 1/4, and 3 and 13/4. So we either have 1 fraction with a 4 in it, or 2 fractions with a 2 in it. Does that make sense? Because the denominators come from here. So it's either 2x and 2x, or 4x and 1x. There's no way to all 4 of them. Right. Well, not the bigger. The more factors the leading coefficient has, the more likely you are to have fractions. We could have 2 fractions divided by 2, or 1 fraction divided by 4. Yeah, but they might be imaginary fractions. So as far as real numbers go, we could only have up to 2. All right. Let's try 2. None of the negatives, right? Am I missing any terms? Nope. 4, negative 44, 145, negative 114, and 26. Drop the 4. That turns into 8. Negative 36. That would be negative 72. What is that? 73? 73 times 2 is 146. And that would be 32. Multiply that by 2, it doesn't work. So we now know 2 is out. No, it can still be 13 because that other 2 might come from an imaginary number. Okay. So somebody's going to need to run a calculator here. We're going to try 13. Drop the 4. 4 times 13. 52. That's 8. 13 times 8. 104. 200. 249. Multiply that by 13. It's going to be huge. It's not going to work. Let's try 26. So 4 times 26 is 104. And then negative 44, that's going to be 60. 26 times 60. Okay, is this going to work? No, they're not. Okay, good point. We got rid of the 26, so I said only 2 of them can be fractions. No. So we're probably this this is out. That can't happen, right? We've got rid of all of the whole numbers, and we know that at most we have 2 fractions. So we're either looking at this or we're looking at this. Probably the middle one, because it would be really hard to start guessing imaginary numbers. We haven't gotten into that. So we need to guess fractions. Is that 13 over 2? So 13 over 2. All right, somebody with a calculator. That's actually going to be 26, right? 26. And negative 44 plus 26, 18. Negative 18. 13. I don't know what 13 times 9 is. 117. Negative 117. So that would be 328. 28 times 13 over 2. 182. And we end up, that's not going to work. The signs are wrong. Okay. 13 over 2 didn't work. It is. 1/4. Well, why did I not guess 1/2? Well, if 13 over 2 didn't work, then the chances of 1/2 working, if 13 over 2 worked, then 1/2 would have to work, because we need a leading coefficient of 2, or of 4. So I'm not going to guess that one because 13 over 2 didn't work. All right. 1/4 of 4 is 1. That will be, oh, I don't know. So this one's not going to work, right? We're going to end up with all sorts of decimals and fractions that we don't want. I overlooked something. I said if 13 over 2 doesn't work, then 1/2 doesn't work, but there's always the chance that 1/2 works twice. So I didn't take that into account. Let's try 1/2. All right, half of 4 is 2. That gives me, well, I forgot that 1/2 could have been a double root. So half of -42 is -21. That would be 124. And half of 124 is 62. That would be 38 plus 14, 52. Did I do that right? -52. And cut that in half, -26 and 0. All right. So we have the root x equals 1/2. What is the factor? This is a little bit more difficult. 2x minus 1. Good job. What's wrong? Well, we don't know yet. But what's wrong with this? Why is the factor not x minus 1/2? The leading coefficient is 4. So, yes. The factor needs to be 2x minus 1. Well, if it was x minus 1/2, then your equation would have fractions in it. But if you have no fractions and this number right here is something other than 1, then you have to put it in the 2x minus 1 form. Okay, because when you multiply it, I guess you could multiply them through and then put a 2 on the outside. Yeah. All right. Now I ended up with a new equation. Okay. Do you notice anything about that new equation? Well, my constant got bigger, right? It's supposed to get smaller, but it got bigger. Everything got bigger. So can I simplify that equation? Is there a number that goes into all of them? 2. 4 doesn't work. 4 does not go into 42. But that's the trick with fractions. Whenever you do synthetic division with a fraction, so it's a 1 divided by 2, that 2 doubled the size of our coefficients. So we need to take those out. Right? We don't want that in there. We want to get rid of that 2. So we'll just simplify by dividing by 2. So we're going to now have 2 minus 21, 62 minus 26. Why did my 26 not get any smaller? I found one of my roots. But usually when you find a root, the constant gets smaller. Yes. The constant was 1. The constant we divided by was 1. So that's why it didn't get any smaller. All right, let's try 1/2 again. So drop the 2, 1, -20, -10, 52, 26, and 0. So I now know that I have 2 copies of 2x minus 1. Okay. And looking down here, can I simplify that equation? 1 minus, or sorry, x squared minus 10x plus 52. Oh, sorry, 26. Glad you guys are here. Are there factors of 26 that add to be -10? 2 and 13, that's as close as we can get. So what does that tell us about the remaining 2 roots? They're either imaginary or irrational. They're either imaginary or they have square roots in them. And in either case, we have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a. All right. 10 plus or minus the square root of 100 minus 4 times 1 times 26 is minus 104 all over 2. 100 minus 104 is negative 4. 10 plus or minus the square root of negative 4 over 2. This becomes 2i. So 10 plus or minus 2i over 2 simplifies to be 5 plus or minus I. Sorry. So back up here. So my roots are 1/2 multiplicity 2, because there are 2 of them, and then 5 plus or minus I. So my factors, 5 plus or minus, or sorry, it's going to be x minus 5 plus or minus I. You can write it like that if you want. No. So we have x, we have the 2 imaginary and the 2. So we have x minus 5 plus or minus plus I and x minus 5 minus I. So 2 complex. And then we have 2x minus 1 multiplicity 2 for a total of 4 factors. So we're looking at this line right here. We got a remainder 0 when we did division. That's 1. And then we did it again, and we got another remainder 0. And because Nate graphed it. All right. So